We will now study the electrical emergency configuration. As there are a lot of events which happen at the same time in the aircraft, we will show these events in a sequential order. Let's assume we are in flight and no previous faults have occurred.
As you can see, the first consequence is that the power supply for the first officer's PFD and ND, the captain's ND, and the lower ECAM is lost. The SOP recommend in such a case that the captain will fly the aircraft while the first officer does the ECAM action. Note, another consequence is the loss of MCDUs 1 and 2.
After clearing the master lights and stopping the alarms, observe that on the emergency electrical power panel, the red RAT and emergency generator fault light is illuminated, meaning that the emergency generator is not yet online.
After a short lapse of time, the RAT and the emergency generator light disappears. The emergency generator is now running and supplying the system. Notice that with the emergency generator online, the power supply to the captain's ND has been restored. Note, MCDU1 is also recovered.
On the engine warning display, you can read that the autopilot has disengaged. Let's deal with this first. To continue the procedure, we will clear this line by pressing on the clear key.
Read the title of the failure. The red emergency configuration title means that you are in an electrical emergency configuration. The red message, Land ASAP, orders to land as soon as possible.
Observe that you have to maintain a minimum speed when the route is extended. Caution! Below this minimum speed, the route will stall, and the aircraft will only be supplied by the batteries. On batteries only, expect to fly approximately 20 minutes.
The pilot flying will ask you to perform the ECAM actions. You will try to reset the generators. Here, this will be done for you. The reset of the generators has not been successful. Before continuing with the procedure, let's look at how to access an ECAM page when the lower ECAM is not available.
An ECAM page can be called up on the upper ECAM by pressing and holding its related system key on the ECP.
The page is displayed on the upper ECAM as long as the associated key is maintained pressed. On the ECAM electrical page, note that the emergency generator supplies the AC essential bus and, via the essential TR, the DC essential bus. As soon as the ECP push-button switch is released, the engine warning display is displayed on the upper display.
As the previous reset of the generators was not successful, we will carry on with the procedure by pressing the bus tie push-button switch.
The bus tie push-button switch in the off position segregates the two sides of the system. By doing this, a short circuit can be isolated and might give you the possibility to reset one generator. The procedure asks you to try to reset the generators again. Here, this will be done for you.
Again, the reset of the generators has not been successful. The next action will concern the ignition, as the fuel pumps are not available and so the engines are fed by gravity. We did this selection for you. Avoid -G and apply the gravity fuel feed procedure, QRH. Then, the flight augmentation computer, FAC1, must be reset. We did it for you. This allows the recovery of the rudder trim system, but without trim position indication. And on the PFD-1, the characteristic speeds, the speed protections, and the speed trend arrow. Then the bus tie push-button switch must be set back to auto. This may allow the APU generator to take over on at least one side after starting the APU. Note: the APU must be started only below flight level 250. So, the bus tie push-button switch has been set back to auto. Then below flight level 250, you may start the APU only if it is available. Note: when the APU master switch push button is set to on, the batteries are connected to the DC BAT bus for a maximum of 3 minutes. As the next step concerns another system, we will stop here and study the indications on the right side of the engine warning display. Notice the amber flight control, auto flight and air system titles. This means that these systems are affected by the boxed primary failure. Their related procedures are stacked after the current one and will appear with the completion of the primary failure procedure. For that, we have cleared the boxed primary failure for you. After clearing the affected system titles, the memo is displayed with the white STS. Again, the related key on the ECP must be pressed and held to display the status page on the ECAM upper display. As long as the STS key is kept pressed, the status page is displayed and can be reviewed. The listed inoperative systems are those seen by the ECAM. For more, refer to your documentation. Even if the rat is able to hydraulically drive the emergency generator correctly down to 125 knots, the approach speed should not be below 140 knots. Let's see what happens when the rat stalls, or when the aircraft is already on ground, with the speed below 100 knots. As soon as the rat is not able to hydraulically drive the emergency generator, the electrical network is automatically transferred to the batteries and to the static inverter. As a consequence, the DC and AC essential buses are still supplied, but they are partially shed, leading to the loss of the MD1 and the MCDU1. Note: this can be checked on the ECAM ELIC page, if it has been selected, of course for training only. But when the aircraft is on ground and below 100 knots, the DC BAT bus is now supplied, allowing also the start of the APU, if available. On ground, if APU generator cannot be connected to the electrical network, as soon as the speed is below 50 knots, all remaining display units are lost.
We will now review some indications we did not have the opportunity to see when performing the previous procedures.
As a result of the loss of AC Bus 1 and AC Bus 2, and provided the speed is above 100 knots, the RAT is automatically extended. During the RAT extension, before the emergency generator comes online, the electrical system is powered from the batteries and the static inverter, as shown, for training only on the selected ECAM ELIC page. Note: the approximate flight time on batteries is 20 minutes. If the RAT fails to extend, or if the emergency generator fails to be online, the red fault light on the emergency ELIC power panel will remain on, and on the engine warning display, the related procedure is displayed. Notice a new action is displayed as the emergency generator is not online. So, we did it for you. But as you can see, it is not successful. Also, the engine generator resets are not successful. As the rest of the IMER config procedure has been already studied, We cleared it in order to display the next procedure. Note, if the RAT has failed to extend, the green memo, RAT out, will be not displayed. Also, the APU, if available, can be started, but only when the aircraft is on ground and below 100 knots. Now, let's assume we are in flight. A generator overload has just occurred. Observe, on the ECAM ELIC page, the related gain and load indications are in amber, indicating that the load is above 100% of rated output. On the ELIC panel, an amber fault light comes on, helping you to locate the push-button switch corresponding to the procedure and in order to reduce the load on the faulty generator. So, we did the action for you. Observe, on the ECAM ELIC page, the white galley shed appears and the load indication has returned to normal. Note, all galley circuits, and if installed, the in-seat power and the IFE systems are not supplied. Now, let's assume we are again in flight. A smoke has been detected in the air extraction duct of the avionics ventilation system. Observe, the ECAM ELIC page has been automatically displayed. On the engine warning display, after the ECAM actions are done, you have to refer to the QRH in order to set manually the emergency electrical configuration. On the emergency ELIC power panel, an amber smoke light comes on, helping you to locate the push-button switch corresponding to the QRH procedure. Note, here, we will see items belonging to the electrical system. When the Gen 1 line push-button switch is set to off, the generator 1 line contactor is open. This connects the AC bus 1 to the generator 2, and the fuel pumps, normally supplied by the AC bus 1, are transferred to the output of the generator 1 in order to avoid the fuel gravity feeding configuration when the emergency ELIC configuration is set. To set the emergency ELIC configuration, the RAT and emergen push button must be pressed to start the emergency generator. Then, when it is online, as shown on the ECAM ELIC page, the APU Gen and Gen 2 push button switches must be set to off. As soon as the Gen 2 push button switch is set to off, the emergency electrical configuration is set, as shown on the engine warning display, and also on the ECAM ELIC page, when it is maintained displayed on the engine warning display. So, we will stop here, as you should continue to apply the QRH to know which part of the ECAM has to be followed. When a green circuit breaker, CB, has dripped for more than 60 seconds, an ECAM caution is triggered and indicates which panel is affected. Note, the black CBs are not monitored by the ECAM.